Why is variational inference key to variational autoencoders? Imagine trying to understand a complex puzzle where each piece is a mystery. Now, think about how a computer can learn to generate new, similar puzzles. That's what variational autoencoders do, and variational inference is the secret sauce behind their magic. Variational inference helps these models handle tricky probability problems that are usually too complicated to solve directly. Variational autoencoders are designed to learn a smooth, continuous way to representing data in a smaller, easier-to-manage space called the latent space. The challenge is figuring out the probability distribution of these hidden variables based on what the model sees. Doing this directly is often impossible because the math gets too complex. This is where variational inference comes in. It introduces a simpler, manageable family of probability distributions to approximate the true, complicated one. Think of it as creating a rough sketch of a detailed picture. The encoder network in a variational autoencoder learns this approximate distribution. Instead of mapping data to a fixed point, it maps it to a probability distribution, capturing uncertainty and variation in the data. During training, the model tries to do two things at once. It aims to reconstruct the original data as accurately as possible, which is called minimizing the reconstruction error. At the same time, it works to make sure the approximate distribution is close to the true prior distribution over the latent variables. It measures this closeness using a concept called the Kullback-Leibler divergence, which tells us how different two probability distributions are. By reducing this divergence, the model ensures that the learned latent space is smooth and meaningful. This process allows variational autoencoders to generate new data that looks like the original training data but isn't an exact copy. For example, they can create new images, texts, or sounds by sampling from the learned latent space. Generative AI models like DALL-E and Midjourney use these principles to produce diverse and coherent images from text prompts. In essence, variational inference is the key to making variational autoencoders work efficiently. It turns a complex, intractable problem into a manageable optimization task that deep learning can handle. This approach makes VAs powerful tools for understanding and generating data, opening doors for creative applications and smarter AI systems.